बिस्मिल्लाहिर्रहमानिर्रहीम। रब्बी ज़िदनी इल्मा, ऐ मेरे रब मेरे इल्म में इजाफ़ा फरमा। अस्सलाम वालेकुम class, I am your physics teacher Iram. Today we are going to start new chapter number 11, sound. As we have discussed in the last topic, in the last chapter about simple harmonic motion and waves, you are familiar now with the term waves. And we have just studied the water waves in the ripple tank and some characteristics of water waves. Today we have to discuss about a different type of wave called sound waves. It means the sound also travel in the form of waves. And waves is a disturbance. It is actually a disturbance in any medium which is carried in the form of waves from one position of the medium to the other position, and the waves carry energy. It means the waves carry energy with them. So sound is also a form of energy that can be carried in the form of waves from the producer to the listener. Now let's discuss some basic properties of the sound waves. First of all, it must be clear that the sound waves, sound is produced by vibrating bodies. It is produced by vibrating bodies, or the vibrating bodies produce sound. Vibrating objects produce sound. From your everyday life, you also know that the vibrating objects produce sound. For example, when we hit anything, the medium is disturbed and a sound is produced. Whenever you pluck the strings of a guitar, the sound is produced. Or you also know that your heart beats and produces sound. Some other organs like lungs also vibrate to produce the sound. Vibration is actually the movement of the particles of the medium, to and fro motion of the particles of the medium, and due to that medium, due to that vibration, the sound is produced. You can also check whether your sound is also produced due to some vibrations or not. Put your finger on your neck and say something. You will feel the vibration of your vocal cords. It means your vocal cords vibrate to produce sounds. Hence we can say that all the vibrating objects can produce sounds. And the doctors, as you know that the human heart beats and the lungs also vibrate, the doctors use stethoscope, an instrument which is used to hear the heartbeat, and that is an instrument used to check the patient's heartbeats. So first of all, we have seen that sound is produced by vibrating bodies. Let's see an activity. A tuning fork is here. Tuning fork is a laboratory instrument which is used to produce sounds, and it is used for some experiments that can be done in the laboratory. It is a tuning fork. It has two prongs. Whenever it is hit by something, it starts to vibrate and produce sounds. When it is hit against a rubber pad, its prongs will start to vibrate, and you can hear the sound produced by these prongs by taking this tuning fork near to your ears. You can see you can hear the feeble sound produced by the vibration of this tuning fork. You can also check whether, as it is a hard material, it is made up of steel or something, so it is their vibrations are very you can see faint. They are very they are not so much prominent, but you can hear the sound, so that you can know that the prongs are vibrating. You can also check whether it is vibrating or not. You can hit a hanging ball by this vibrating tuning fork. The ball will start to move. It means that it can show that the prongs are vibrating. or you can also put the vibrating tuning fork in some water so that you can check the splash will be there, and you can know that the prongs are vibrating. So it is clear that all the vibrating objects produce sound. If there is no vibration in the bodies, no sound will be produced. Now we have to check whether sound is a form of which type of waves are the sounds. So sounds are mechanical waves. Sounds are mechanical waves. Why? As you know that there are two types of waves, mechanical and electromagnetic. Electromagnetic are such type of waves which can pass through from even vacuum. They can pass from all types of mediums and even vacuum. They do not require any material medium. They do not require any particles to take to move to or to propagate. But mechanical waves are such type of waves which require material medium for their propagation. They require material medium for their propagation. It means they require some particles to take the energy from one part to the other. You can also take the example like this, as the light energy and heat energy is the type of electromagnetic waves, as the sun is the main source of light and heat, and we are getting light and heat every day in our daily lives from the sun, and they are electromagnetic waves, so they are passing from each type of medium between sun and the earth. But there are also different reactions taking place on the sun and stars, but we cannot hear the sounds of that reactions, chemical reactions or bombardments on that planets and stars. So we can say that the sound waves are not electromagnetic waves because they cannot pass from the medium. We can also see an activity, do an activity to prove that the sound waves are mechanical in nature. Take a bell jar, glass bell jar, from which you can see the process going on inside it. Take an electric bell hanging inside the bell jar. You can see the figure 11.5 from your books. Now you have taken the bell jar and an electric bell is hanging inside it with the help of a cork. That electric bell jar is connected with the power supply outside the bell jar. First of all, the bell jar is filled with the air, and when the power supply is on, the hammer of the electric bell will start to vibrate and a loud sound will be produced. The bottom of the bell jar is connected with the vacuum pump. When you create vacuum inside the bell jar, or you take the air out from the bell jar, the electric bell, you can see the electric bell, the hammer of the electric bell still vibrating, but the sound will be fainter now. What is happened here, that you have taken the air out from the bell jar. Now there are no air particles which can transfer the sound energy, so the sound will be fainter and fainter, and in the end you can see if the perfect which is not possible, but whenever you have reduced the amount of air in the bell jar, the sound will be fainter and will be vanished, and you will just see the vibrating of hammer of the electric bell, but no sound will be there. So it means that the sound waves are mechanical in nature. They always require any material medium for their propagation. That medium can be solid, liquid or gas, but there must be a medium there. As you know that air is a mixture of gases, so air is we can produce sounds and hear sounds from the air, from liquids the sound can also travel, uh, just like the water in the seas produce sounds. It is moving, it is vibrating, and the particles are moving, and you can hear the sound of vibrations of that water. So the sound waves can also pass from the liquids, and in solids you can also hear the sounds across the walls of your house. Whenever the doorbell rings, you can hear its sound across the walls. So we can say that the sound can pass from solid, liquid and gases. Its speed will be changed in different kinds of medium, but the medium is always required to produce or hear the sound waves. And now we have to see what is the nature of sound waves. As you know that mechanical waves are of two types, transverse and longitudinal. Now we have to see what type of mechanical waves is the sound wave. So let's take the prong again. A vibrating prong will be, suppose this is the mean position, it is the resting position of this prong. When it will be hit against the rubber pad, it will start vibrations. For example, this is the mean position. Vibration means it will move forward and backward from its mean position. Suppose A and B. Whenever it will move from O to A, it will compress the air layer present in front of it, and whenever it goes back to B, what will happen? It will press the air layer present in this side, and it is a very rapid process. The vibration is a very rapid process. So what happened here? Whenever this air, the layer of air is compressed, it will move in the backward direction and the layer will be relaxed now. It means a series of compressions and rarefactions will be here, which proves that the sound is a form of longitudinal waves. Hence we can conclude that sound waves are longitudinal in nature. Sound is a type of longitudinal waves. Sound waves is a type of longitudinal waves. It travels in the form of series of compressions and rarefactions. You know about compressions and rarefactions. The layer of air in which the pressure is increased, that layer is called compression, and the part of the longitudinal wave where the pressure is lesser, it is called rarefactions. It means the particles of the air are vibrating about their mean positions, to and fro about their mean positions. They are just transferring their energy from first layer to the second layer, say that. So in the form of series of compressions and rarefactions, the sound wave travels from one place to another. So that was all about the sound waves. Here we have seen that sound is always produced due to vibrating bodies, and sound is a form of mechanical waves, and sound is longitudinal in nature. I will also show some clips after this and some pictures, so that you can easily understand all the stuff related with sound. In case of any problem, you can ask and